Hi, our project is on simulation of gas station and under the guidance of Dr. Weihang, and I am Jairam Godapati and he is Karthik Jaimani and he is Arun Kumar Jagdishan. The contents of this presentation which we are presenting here is introduction, objectives, model description, animation, results and conclusion. Coming to the introduction, we collected our data from Weihang Super 8 gas station, and it has two diesel pumps and 6 gasoline pumps, and we considered one cashier and other two. There are 2 waiting spaces for the gas station, which we considered as resources, and the cars and other types of automobiles which are coming into the station, we considered as them as entities. And there are 2 types of people who come to fill their tanks: the people who pay by cash and the people who pay by card. The one who paid by cash, they go into the retail store which is open and they pay the cash and they come back and fill their tanks up. The other people are the one who directly go to the gas station and they put their card there and they process their card and they fill their tank up. And the one more limitations for this gas station is like it works only 16 hours a day. The other 8 hours it doesn't work. It's like the retail store doesn't work. So the people who can process by card only can fill their tank up. The people who come with the cash can't do it. So can't do it. The next slide is objective of our presentation. Objective of our project is like collecting the data on different days and creating a model on gas station process. The main objective is like here the gas station is open only for 16 hours a day. So we want to make a simulation model and run it and see whether when it is done for 24 hours a day and how economical is the gas station, how economical it will be for the owner over there, and also optimize the pumps. It's like whether the station has 2 diesel pumps and 6 gas pumps, whether they are optimum, whether they are utilized nicely or not, whether they are needed for the amount of people which they are coming or not, is our objective. To determine is our objective. Next one. And we did data collection on 2 days, which we took 2 hours time, 2 hours permission, and which took the data from them. And according to the data, the arrival time of each vehicle is like the difference between the arrival time of each vehicle is exponential of 6 minutes. And the process time for the card is like the card has a process like when we put it'll ask some data about pin code, the pin, and all those stuff. It is mostly taking from 1 minute to mostly from 30 seconds to 1 minute. So we took it as a maximum of exponential of 1 minute. And the processing time for the filling gas process is like 5 minutes, 6 minutes, 7 minutes. So we took a triangular of 4 to 5 and 6 minutes. And the customers who are coming, they are like 20% of customers who are coming are filling up the diesel, and the other customers are filling up the gasoline. And there are 45% of customers who are coming are paying cash, and the other 55% are paying by card. My friend will explain about the flowchart and the model.
Well, if you consider the flowchart, let me take a marker over here. So, okay. If you consider the flowchart, the vehicle arrives over here and goes to the machine model over here, and it's a pump available or not. Here we check whether pump is available or not, and if it's yes, it directly goes to the rotation mode over here where we decide we're going to fill diesel or gas. If the pump is full, and it goes to rotation mode over here, where we checks whether the wait space is available or not, and if it's not available and the entity that's a vehicle just exits the store. And if it's wait filling available, the vehicle just waits over here and till the pump is free and then goes to the pump. At the diesel model, where we decide gas or diesel. If it's diesel, it has a separate model over here, and if it's gas, it has a separate route over here. And the payment, if you consider payment, it's by cash or card, and if it's card, we just did a process model over here, and that's I guess it's 1 minute, and goes to the filling process and just exits the store. And if it's by cash, the entity has to go to the store which is open for 16 hours, and if the store is closed, they just exit the station, and if the store is open, they just goes to pays the cash and does the filling up process and then exits the store. The same thing goes for the diesel thing. So this is our model. We just include the routes and stations over here, and the exits are over here, and the incoming vehicle incoming arrival thing is over here, and here we check whether weight space is available or not, and if the pump is free or not, and over here we check whether, it's a DC model, whether the vehicle is vehicle have to fill gas or diesel, and if it's gas it goes by this way, and if it's diesel it goes here. And the other DC model same as the flow chart. So let's see the model of how it runs. So just close this, and we are going to Arena, and this is our model, and this is our animation. It looks clumsy, I know. So once we are running it, goes on, and we are getting output of 235 with one replication. One replication is not enough, so we'll be running a more replication using pan later on, and we'll be showing a pan in the conclusion. So if you again go to the presentation and the next slide. So this is our animation, and the car comes in. So this model over here, and it comes in the same thing over here, same as the flowchart, and the result will be shown there.
We have actually created two models, one for the 16-hour and one for the 24-hour runtime. We consider like seven different scenarios, and we run them on pan and also verified them on OpQuest. We run the model for 50 replications to get a solid result of the model, and the best result was found out to be 24-hour runtime, which served like 240 customers. Next slide. These are the results for the OpQuest. It's clearly seen that having a single diesel pump and 5 gasoline pump is the best solution for this model, because there are only few people who use diesel pumps, and there are more number of people waiting for the gas pump. So it's more optimized to use 5 gas pumps and a single diesel pump. These are the results for the pan. Here you can clearly see that we have taken the different scenarios of having a single gas pump and having a different type of diesel pumps and different type of gas pumps, and we have run like 50 replications, and we have also run for 16 hours and 24 hours with 7 replications each, and we can see that there are like 240 customers served, and there are no customers left unattended at the model number like 11, scenario 11. We can see that we have served like 240 customers, and now no one is left out of service, and that's the best scenario we can get in this model. And after considering the cost the management has to pay the cashier for running the store for 24 hours rather than 16 hours, we have found out that and also considering having a single diesel pump and 5 gasoline pumps instead of 6 and 2 diesel pumps, we found out that they are like approximately getting $60 per day with our optimized model.
And the model which we showed there is about for 24 hours, and we also created 16-hour model initially, and we put both the models and compared them so that we get the optimized result. And our best process, we also inquired about how much profit they are getting and how much is the maintenance cost, and the result and the conclusion is based on all the costs added and subtracted. Thank you.
Cool, thank you.
Thank you.